Good morning, everyone. So we are into our lecture 9 already. So this lecture will now be moving to the producer theory, and we'll start with the profit maximization problem. Firm and production technology. So since lecture 1, we have been looking at the consumers or consumer theory side, and we have studied the demands, right? Lots of like Higgsian and Marshallian demands and all of those things. And how the consumer choose the optimal bundle either based on the utility maximization problem or expenditure minimization problem. But remember that the market consists of two sides, consumers and producers. So from today or this week, we will be looking at the producer side, or how the producers make decision, which is under a certain assumption of a producer being a profit maximizer. What is a firm? Traditionally, we say a firm takes inputs to produce outputs, but consumers do that too. Like for example, I take groceries to make dinner, and it is known as a household production. But there's one important difference between firm production and household production. A firm sells its output to the market, whereas a household actually consumes its output. It's never been traded. Therefore, the preference of the owners of the firm does not matter, right? Because the owner of the firm does not consume the goods that they produce itself. So the firm's preference actually does not matter. The firm can always first maximize its profit, and the owner can use the profit to buy whatever goods she likes, right? So this table shows the similarities and the differences between the consumers and firm. So consumer takes good and turns the good into utility, whereas firms takes input and turn the input into output. For the consumer, utility function is a process, and it is the process of which is determined by the utility function. Okay, so this thing is a process determined by the utility function, whereas we use for the producer, that is going to be the production function. And the cost of this process is called expenditure for consumer, and it's called cost for the firm. Consumer chooses consumption bundle, whereas firm chooses input combination. Right? Unlike utility, output is cardinal, not ordinal. Utility is ordinal, so the numbers of utility actually is not meaningful. Whereas for the output in the producer's problem, it's meaningful, it's cardinal. So 10 units of output, we know what it means by 10 units of output. So 10 units of output is indeed 5 times more than 2 units of output. And also the diminishing marginal utility versus the diminishing marginal product, right? Firms does not have a budget constraint. We will assume that the firm has access to a perfect capital market. So as long as the production is profitable, it could be financed. So it could have an access to the source of money as much as they want, as long as the production is profitable and they want to operate the production. Production technology, we will think of a production process involving only 2 inputs for the simplicity. So we call them labor L and the capital K. So we don't really, care what is classified as labor and what is classified as capital in this course. We just, L, let's say L is just labor and capital is just capital. And the production function would be Y. Now this is the amount of output. It's a function that depends on the amount of L and K, which are the inputs. So it describes how inputs could be turned into the outputs. Control lines of production function. Just like the utility function, the production function is a two-variable function. If we were to plot the function, we need a three-dimensional graph, right? Because one for L, one for K, and another one for output or Y, because we have Y equal to F, L, K. So we have three variables, right? Two of the inputs and one for the output. So basically we will need three planes. But we will just, try to make our life easier. Just like how we deal with the indifference curve for consumer, we just fix, right? By using the indifference curve, we fix utility value and then adjust the level of input output bundles like X and Y. Now, with the production function, we also gonna fix the output and then adjust the input variables that obtain the same level of output, and we will call that curve isoquant. Isoquant means the same quantity, just like iso utility or the indifference curve in the consumer's problem. So isoquant we have LK, so you can see that pretty much is very similar setup to the indifference curve for consumer, but for the consumer there will be X and Y, right? Two consumption goods, X and Y. Here we are dealing with a two input instead, which is L labor and K capital. And we have Y1, Y2, and Y3. So every input bundles along the same isoquant would yield the same level of output equal to Y1. So as you can see that as we move further away from the origin, we should experience the higher level of output produced due to more amounts of labor and capital bundle. So suppose we have again the Cobb-Douglas utility function, right? So we have L to the power of 1/2 multiplied by K to the power of 1/2. So this is the Cobb-Douglas, one unique form of the Cobb-Douglas utility function. So to derive the isoquant, right, we just need to fix the output to be a constant, whatever the constant is, and then we rearrange this equation so that K is a function of L, right? Because we want K as a function of L so that we can plot that isoquant successfully. For instance, if we choose the constant to be 2 times the square root of 3, right? Then we can rearrange. So we can start with this production function is equal to this units of output, which is 2 times the square root of 3. Then we square both left and right hand side of the equation. We have LK equal to 12 or K equal to 12 divided by L. And this is called the isoquant equation, right? That gives us the output equal to 2 times square root of 3. So you can plot that. We know that K is equal to 12 over L, right? So we can start with L equal to 1. So we can have K and L. Maybe it's better to have L first and K. So we can start with L equal to 1, 2, 3, 4, 5, and so on. So with L equal to 1, K would equal to 12. L equal to 2, K would be 6, 4, 3, 2.4, and so on, right? So we can plot this bundle 112. So we have 112 here, 2, 6, 2, 6, 3, 4, 3, 4, 5, 4, 3, 4, 3, and 5, 2.4. Something like this. Okay, when the output y is equal to 2 times square root 3. And of course, if we change this output, this constant to some other numbers, we will have a higher level of isoquant if this amount of output is a higher value, right? So you can get something like this and so on. So just change these numbers and then plot them accordingly. Let's say that if another one we have actually 2 times square root of 2. So actually this is a smaller, smaller output level. So you have a isoquant for the output level equal to 2/3, not 2/3, 2 times the square root of 2, which is gonna be, based on this equation. And then you get this, okay? Or you can draw the higher isoquant when Q is equal to 5, and you get something like this one. Okay.